Hello. Today I want to look at stoichiometry and I want to show you a real simple way of doing this in just 5 easy steps. And I've chosen a relatively tricky equation here to do so with just to show you how well it works. So this question asks, how much carbon dioxide is produced when 50 grams of oxygen gas is burned with ethane, C2H6, to produce carbon dioxide and water? So I apologize that those numbers aren't in subscript, but I couldn't get that to work. So step number one is to write a balanced equation. And so we look at this and say, all right, we're reacting oxygen gas with ethane, C2H6. So I'll write that like so. The order doesn't matter. And they make carbon dioxide and water. Now that's not balanced. So let's take a look at that. This is also a sort of a tricky one to balance. So there's a sub lesson here on how I balance chemical equations, and a little trick if you come across the problem that this one has. So how I like to do it is to write out all the elements that I have in my equation and make a little table like so with the reactant side and the product side. And then I count everything up. So I have 2 carbons, 6 hydrogens, and 2 oxygens on the reactant side. I have 1 carbon, 2 hydrogens, and 3 oxygens on the product side. Next thing I like to do is just whatever looks easiest. So turning a 1 into a 2 is pretty easy, so I'll do that next. I'll put a 2 there, which balances that out. Great. But of course, that changes my oxygen. So now I have 4 plus 1 is 5 on that side. It's not really helping me, 2 and 5. But I have another easy thing I can do. I can turn a 2 into a 6 by putting a 3 here. So now I have 6. Great. But again, I've changed my oxygen numbers as well. I still have 4 from the carbon dioxides, and I have 3 from the waters, which adds up to 7. Now, here's the problem. So you might say, well, 2 times 3.5 here is 7, and so I'm done. And you could do that. Some teachers don't mind that, but I like to think about these things as real molecules. And since there's no such thing as 0.502s, and you can have an O, but it's not oxygen gas anymore, I don't like that. So my trick when I get stuck in something like this, where everything looks good except for this one element, is double everything. So instead of 3.5 there, I'm going to put 7, which gives me 14 here. And if I simply put a 2, change these to a 4 and a 6, so I just doubled everything that was already there, this should work. So now I have 4 and 4, good. I have 12 and 12, good. And I have 14, and 8 plus 6 is 14. I'm done. So now we have a nice balanced chemical equation. So that's step one, and that should all be review. Let me just get rid of all of that. Now, step two is to find the molar masses. This is another easy one, since you just read these off the periodic table, but we're not going to find it for every chemical in this equation. We only care about 2 things, really. We have one of the molecules, we have some information on, and that's the oxygen gas. Here we know that we have 50 grams of oxygen. That's our known. I like to call that one the known. We know something about it. And this question is not asking about the ethane. It's not asking about the water. It's asking about the carbon dioxide. And so I like to call this the unknown. These are our 2 things. Now, I could have just as easily asked for the water or the ethane, and these steps would be exactly the same. Or I could ask for all 3 of these things, but we won't spend too much time doing all 3 of them. But these same steps will work for any chemical in a chemical equation, whether it's a reactant or a product or whatever. As long as you know something like a mass or a moles about one then you can figure out the rest. And so in this case, we know the mass of one. And I'm doing that because that's all the steps. If you've already given moles, then you can skip some of these steps. We have our known or unknown, and we want to know what their molar masses are. And again, this is easy. We read that off the periodic table. Oxygen is 16, so we have O2, which makes that 32 grams per mole. Note, I do not care one bit about that 7 in front. That's telling me how many of these I have. I want to know what their molar mass is, which is independent of how many we have in a chemical equation. Same thing with the CO2. I take my 2 oxygens and I'm really just adding a carbon, which is 12.01 grams per mole. And so I get a total here of 44.01 grams per mole of the carbon dioxide. So that's step 2, done. Step 3 is that we find the moles of the known here. So this one we know 2 things about now, which means we can find the number of moles. So find moles. And again, if you're given moles in your question, you can skip the finding molar mass and doing this step. You already have it. You can go right down to step number 4 here next. But I want to do all the things that you might possibly have to do. So find moles of the known here. And so that's this. We know something about it. And I'll call this one the unknown. There's nothing special about those other than the word problem gave them to us. So find the moles of the known. Okay, well, I have to use our old friend little m over big M. If this is a new formula to you, you need to go back and watch some other videos or look back through your notes, because this is an equation you need to use an awful lot in chemistry. So little n moles equals mass over molar mass. And so we know both those things about, in this case, it's the O2. And so we take our 50 grams, divide by 32 grams per mole, and I get a nice number, 156 moles, 1.56 moles of oxygen. Great, so we have that, and we need to move on to step number 4 here, and this is the crucial step. This is the thing that allows us to figure things out from different chemicals in a chemical equation. This is the use the mole ratio to find moles of the unknown. And so you'll see this different ways, like using fractions and things in some sort of what am I trying to say here? Dimensional analysis formats, where you'll see things listed out as numbers times a fraction times another number times so on and so forth. I like to keep this a little bit simpler and use a cross multiplication method. So if you don't like this, do this the way you normally would, but this is how I like to do it. I like to look at my known, something I know about, and make a ratio with the thing that I'm asked about, the unknown. And so I do know those things. This is where the balanced chemical equation comes in. The 7 and the 4 will give us our mole ratio. So I'm going to put a 7 here and a 4, which means for every 7 oxygen molecules, we will make 4 carbon dioxides. So if we have 14 oxygen molecules, we will make 8 carbon dioxide molecules, so on and so forth. But unfortunately, we don't have nice, easy numbers to work with. And again, I chose this equation because this isn't like a 1-to-2 ratio or a 1-to-1 where it's really easy. These are sort of a weird ratio here, 7-to-4. And so what we do then is take the moles. That's why we did in step 3, or if you already have them, you can just skip to this step. And that ratio will be the same. That is a number of them. It's not an easy number like 7 and 4, but 1.56 moles is a counting number of how many oxygen molecules we have. And so how we figure out what this x is simply cross multiply. And so I'll take 7 times x and 4 times 1.56. So I get 7x equals 6.24 here. And then to get x by itself, I simply divide out the 7. Now, this is the exact same thing as you do when you write out all the fractions and in a big long list of multiplication stuff. I just like the look of this and the simplicity of this a little better. And so we divide those two numbers, and I get 0.89 moles of carbon dioxide. So look at that, easy enough. That's the crucial step. Now, the last step is to use that along with the molar mass we found in step 2 to solve for the mass of the unknown. And in this case, that's CO2. And so we use this same equation, but we rearrange it so that we get mass is moles times molar mass. And I put in my moles of carbon dioxide times the molar mass of carbon dioxide, which is listed just off screen here. And we do that, and we get a mass of 39.2 grams. And so there is our final answer. And so if you follow these 5 steps for any chemical equation, you should get the right answer when doing gravimetric stoichiometry.